I welcome you all for this class. In this video, I would like to explain EAPCET previous year questions related to charges and electric fields. So let me read the question. Two charges of equal magnitudes and at a distance r exert a force F on each other. If the charges are halved and the distance between them is doubled, then the new force acting on each charge is. That is what we want. So according to the question, we have two charges. Both the charges are of equal magnitude and at a distance r. So I have two charges. This is charge 1. This is charge 2. See, now these two charges are separated by a distance r. There may be force of attraction or repulsion between the two charges according to Coulomb's law. So for instance, he is not mentioned anything about the nature of the charge. So let us assume both charges are positive charges. This is plus q, this is also plus q. So there will be force exerted by this left hand side charge on the right hand side charge in this direction. Why? Because it is force of repulsion. Means this left hand side q will make the right hand side charge q to move away from it. Similarly, there will be force exerted on this left hand side charge by the right hand side charge in this direction, the left. Now initially they are separated by a distance r. According to Coulomb's law, F is the force. That force I am writing F is equal to 1 by 4 pi epsilon q. See, actually there are two charges, both are of equal magnitude. That's why I have taken q. So q into q by r square. Here epsilon is the permittivity. So this epsilon can be written as epsilon naught into epsilon r. For free space, this epsilon r will be equal to 1. So if he is given some medium having epsilon r with a different value, then you have to include. Otherwise, you can write epsilon is equal to epsilon naught. Okay. So according to the problem, first condition, I got the force F is equal to 1 by 4 pi epsilon q into q by r square. Now in the second case, he is saying that the charge was half. That's why this q becomes q by 2. This q will also become q by 2 because he clearly mentioned that both charges are half. And now he said he separated those equal charges at a distance twice that of the earlier distance. Earlier we assumed that the distance is r. Now it is doubled. That's why those two charges made half becomes q by 2 and are separated by a distance to r. Now according to Coulomb's law, again there will be force of repulsion between these two charges if these two charges are of same polarity. If you assume one as positive, one as negative, there may be attractive force. There may be attractive force between them. So now I am assuming in the second case the force as F dash. Then F dash is equal to 1 by 4 pi epsilon q by 2 into q by 2 by 2r whole square according to Coulomb's law. So I have rearranged 1 by 4 pi epsilon q into q by q square by 2 into 2. It will become 4 divided by 2r whole square is 4r square. Now I rearranged it 1 by 4 pi epsilon q square by this 4 into 4 becomes 16. So if you see this 1 by 4 pi epsilon into q square by r square is nothing but this F. So I can write F dash is equal to F divided by 16. So option D is the correct answer for this question. Okay, let me go with the next question. First, let me read the question. Charges on two identical metal balls is Q and 3Q. They are kept at a same distance after an initial contact. This is very important. what is the ratio of initial to the final force? See, initially we have two charges. One is having a magnitude of q, another charge is having a magnitude of 3q, and they are separated by a distance. He didn't mention anything, but at the same distance. For instance, in the first case, I am assuming they are separated by a distance r. Okay. So, in the first case, what will be the force? Force is 1 by 4 pi epsilon naught into q into 3q by r square. So, here I have taken as 1 by 4 pi epsilon naught. Here you see 1 is constant, 4 pi is constant, epsilon naught is the also a constant, it is not changing. So that's why I am taking this 1 by 4 pi epsilon naught as k. So then F1 becomes k into q into 3q, that is 3q square divided by r square in the first case. Now what he did, after an initial contact, now they are kept in contact. So this q charge, a metal ball having a charge of capital Q and another metal ball having a charge of 3q are now contacted. Whenever these two are contacted each other, see the charge inside this 3q is more. Obviously the charge will transfer from high charge body to low charge body. So when you kept in contact, now the charge in each metal ball will becomes average of these two charges. So average of these two charges is nothing but q plus 3q by 2 because they are two charges. So 4q by 2, that is 2q. Now each charge of each ball now became 2q. Now again those two charges are, after initial contact, they also kept at the same distance, that you have to remember. So as the distance is same, I am taking here also r only. Now according to Coulomb's law, there will be force of attraction or repulsion. Here both charges are positive, there will be obviously force of repulsion. So that force F2 is given by, see again 1 by 4 pi epsilon naught, I am writing it as k as it is constant. 2q multiplied by 2q, it will become 4q square divided by r square. So now he is asking us the ratio of initial force to the final force. Initial force is F1, final force is F2. So if I make F1 divided by F2, I'll see all these will be cancelled. K into q square by r square, k into q square by r square will cancel. F1 divided by F2, we'll get it as 3 divided by 4. Means F1 is to F2 is equal to 3 is to 4. So 3 is to 4, option 2 is the correct answer. Let me go with the next question. Two charges Q1 and Q2 are placed in vacuum at a distance d, and the force acting between them is F. So we have two charges Q1 and Q2, and they are separated by a distance d, and the force acting them when they are separated by a distance d is F. If a medium of dielectric constant K is introduced, now he introduced a medium of dielectric constant having a dielectric constant of 4. Then the force now will be, after introducing this dielectric medium, what will be the force? That's we want to find. So before going to that, first condition, there are two charges with us, Q1 and Q2. So Q1 is one charge, Q2 is another charge. Those two charges are separated by a distance d. So according to Coulomb's law, what we know, F1 is equal to 1 by 4 pi epsilon, actually it is epsilon. Epsilon r is 1 for vacuum or free space. That's why in place of epsilon r I have written 1. So epsilon becomes epsilon naught Q1 into Q2 by, as the distance here in the problem itself he is given as d. That's why I have taken the same d. So d square. I calculated F1. Now in the second case what he did, the charge was same, Q1 is as it is, Q2 is also not changing, it is as it is, and the distance between them also d only. But only thing that he made a change is he introduced a medium of dielectric, the dielectric constant 4. Now you include that 4 in the formula. So F2 is 1 by 4 pi epsilon. Epsilon is what? Epsilon is epsilon naught into epsilon r. Here epsilon r is 4. That was given in the question. So that's why in place of epsilon r, I have written 4 and I wrote the formula again. F2 is equal to 1 by 4 pi epsilon naught into 4 into Q1 Q2 by d square. So if I make this 1 by 4 kept outside, then I can write 1 by 4 pi epsilon naught into Q1 Q2 by d square. If you observe clearly, this 1 by 4 pi epsilon naught into Q1 Q2 by d square is nothing but our f. See, he asked us to take it first f1 as f. That's why I can replace f1 with f. So f2 is equal to 1 by 4 times f. So 1 by 4 is what? 0.25 f. So 0.25 f is the correct answer. So option D is the solution for this problem. Okay. Let me go with the next question. 3 charges 2q, q and 4q are placed on the x-axis at position 0, r and 2r respectively. If the force on charge 2q at x is equal to 0 is 0, then the magnitude of small q is. See here we have 3 charges placed at 0 and at a distance r, and from 0 at another distance 2r, 4q was placed. That's what is given in the question. Now the net force acting on this 2q, which is kept at origin, is 0. In the problem itself he is mentioned clearly, the net force acting on this charge 2q is 0. Then the magnitude of small q he is asking. See, as the net force is 0, on this 2q there are 2 forces acting. So those 2 forces must be equal and opposite, then only the net force becomes 0. So that's why if I want to have F2q is equal to 0, then what I have to do? See, first I am calculating the force acting on this 2q charge which was kept at origin due to the small q charge which is at a distance r from the origin. So I am naming that force as F2q due to small q. So force on this 2q due to this small q charge will be k into 2 into capital Q into small q by r square. Similarly, there is another force due to this 4q charge on the 2q charge. So that is I named it as F2q 4q, means the force on this 2q charge due to another charge of 4q is given by k into 2q into 4q by 2r whole square. Why I have written 2r here? See, the distance from origin to this 4q is 2r. That was given in the question. So that's why I have taken 2r whole square. So now I got 2 forces. The forces must be equal and opposite, then only the net force will become 0. That's why I have taken F2q small q is equal to minus F2q 4q. So if you see here, this k will cancel, q times this r square will cancel, for 1 the, for 2 the, this 2 will cancel. We left with small q is equal to minus q. Okay. See here, out of 2 q's, 1 q will be cancelled, 1 q we left with. Okay. So that's why q is equal to minus q. I would like to stop here for today. Thank you.